Hello everyone, welcome to the past year NEET questions discussion on thermodynamics chapter. So here we are in the part 3, and we have covered the questions in most recent years in part 1 and part 2. So those who are looking at this video, right, in the part 1, part 2 also you can refer to it, so that the relevant models of questions you will be able to correlate them better. Okay, so we'll start with the question that has come in 2011. Anyway, the enthalpy change for the reaction, there is a reaction that is given. Okay, so 4 gaseous hydrogen atoms are combined to give 2 hydrogen molecules. Okay, what is the enthalpy change? Minus 869.6 kilojoules. Okay, this is not in terms of the 4 atoms of hydrogen combined to give 2 molecules of hydrogen. It is more like 4 moles of 4 moles of hydrogen atoms. Okay, so they are combined to give 2 moles of hydrogen molecules. Okay, so for that what is the, we can look at this from the unit. Okay, so what is the enthalpy change for this? This is what? Minus 869.6 kilojoules. Okay, other than what they are asking, the dissociation energy of hydrogen bond evolutionality they are asking. Okay, so dissociation energy of hydrogen bond and so we are talking about the dissociation of the bonds. So if you just reverse this given reaction, so reverse panna, so 2 moles of hydrogen molecules will be giving us what? 4 moles of hydrogen gaseous atoms. Adukana, what is the enthalpy change? Because when you reverse a reaction, right, enthalpy change it will become minus of the original enthalpy change. So it is going to be what? 869.6 kilojoules. Okay, but in 2 moles of hydrogen molecules see, in each hydrogen molecule there is one hydrogen bond. Okay, so we are talking about 2 moles of hydrogen bond dissociation. What is the enthalpy change? 869.6 varudhu. Rendu pakka we divide this by 2. What you are going to get? H2 gas, which means 1 mole of hydrogen molecules will dissociate to give, both sides we are dividing by 2. Okay, so that will be giving us what? 2 moles of hydrogen atoms. Adukana, what will be the enthalpy change? Because when you multiply or divide a reaction by a factor, enthalpy change also will be multiplied or divided by the same factor, which means what? 869.6 kilojoules divided by 2. What is it? That will be 4. That will be what? 434.8. so paranga, this is the enthalpy change involved in this particular reaction. So what is it representing? Is 1 mole of the hydrogen bonds getting broken. Either bond dissociation energy. What do we call it as? Bond dissociation energy, right? That is the energy required to break 1 mole of the bonds. So what is the answer for this? Plus. Bond dissociation energy will always be what? Positive. Okay, so plus 434.8 kilojoules. Okay, so from the given the reaction or the enthalpy change we just did the modifications. Okay, so when you change a equation accordingly, and the enthalpy also will get modified. For equation reverse panna, enthalpy change will become what? Negative of the original reaction or the enthalpy change. If you multiply equation by a factor or divide by a factor, means the corresponding enthalpy change also will be multiplied or divided by the same factor. Okay, Other question paranga. This is a question that has come in the 2011. Which of the following is correct option for free expansion of an ideal gas under adiabatic condition? So adiabatic condition, when they say adiabatic condition, right, what it represents? We are enclosing the system within adiabatic walls. There will be no heat exchange between the system and surroundings, which means Q or value will be what? 0. They are saying free expansion. Free expansion, if you have a gas, you have a gas in that particular system, the gas will be expanding against the external pressure. Free expansion, the external pressure is what? 0. So the expansion in vacuum, it will be like free expansion. External pressure 0 then what is the work formula? Work is what? work will be minus integral P external dV dana. This is the general work expression. So this is the general work expression, right, in thermodynamics. So the P external 0 means the total integration of the value will be what? 0. Means in free expansion case or expansion in vacuum, adala work value will be what? 0. So Q already namakku 0 irukka because it is what? Adiabatic. Okay. Then we have W also 0 because this is free expansion. Now first law enadi, what is the first law concept? Del U is equal to what? Q plus W dana. So Q is 0, W is 0 means del U value is what? 0. Del U is equal to what? NCV into the delta T. Okay, means the delta T value will be what? 0. Delta T value will be what? 0, because if the internal energy value is not changing means it represents what? For an ideal gas. For an ideal gas, the internal energy will be depending on only the temperature part, right? So delta U 0 means other delta T corresponding value also 0 means this is also a constant temperature process. Okay, so correct option in option C. Q value will be 0 because it is adiabatic. W 0 because it is a free expansion. Q 0 W 0 means delta U value also will be 0. Delta U 0 means ideal gas, right? Ideal gas case la delta U expression and NCV delta T dana means delta T also will be 0. Paranga option C will be the correct answer. Another question pola, this is a question that has come in the mains paper 2011. Okay, so previously we used to have this two, all India pre-medical test, AAPMT prelims and mains, and so we used to have two levels. Okay, so then this is a question that has come in the mains paper. Consider the following processes, and then they are giving us three processes or three reactions. Okay, other corresponding delta H values also they have given. For B plus D giving rise to E plus 2C and the reaction of the delta H value we calculate. What we are supposed to do? We have to calculate delta H for that unknown reaction. What is the unknown reaction? B plus D giving rise to E plus 2C. Okay, this is going to be solved based upon the Hess law of constant heat summation. This is going to be based upon what? Hess law of constant heat summation. Hess law concept the enthalpy change. What is the Hess law concept? Enthalpy change of overall reaction. Enthalpy change of overall reaction is equal to what? Is equal to sum of the enthalpies of individual reactions. Is equal to what? Sum of the enthalpies of the individual reactions. Other than a Hess law concept. Okay, so we should arrange the given equations in such a way that and the given equations oda combination add panna, we should get this overall equation. So on the unknown equation we will consider it as what? Overall equation madri. Okay va? So the given equations we should arrange and we will be required to make some modifications if need. Okay, if needed we should modify the given equations. Modify pannadukku we should see and the ella combination add panna we should get the overall equation. Adu eppadi panna theriyuma? Adukku oru silla clue or hint we will take. Okay, so paranga the overall equation la B is coming in the reactant side. The given equations la we have B coming in two places. Edula B is coming in the first equation and the B is also coming in the second equation. Okay, adukaprom D paranga, D is coming in second equation and the third equation. But E is coming in only one equation. One equation we are getting E. What is that? That is the equation 3. Equation 3 we are getting E. Okay, but overall equation E is coming on the product side. Overall equation E is coming on the product side. Okay, so now we the overall equation B plus D giving rise to E plus 2C. Okay, so overall equation E is coming on the product side. Okay va? But equation 3 where is E? E is on the reactant side. 1 mole only. It is 1 mole only. But equation 3 la E is coming on the reactant side, but நம்ம overall equation எங்க வருது E is coming on the product side. அப்ப என்ன பண்ணணும் தெரியுமா, in the equation 3 we are going to modify. எப்படி, we have to reverse it. reverse பண்ணா என்ன வருது பாருங்க, 2d giving rise to, அப்படியே reverse பண்ணணும், அவ்வளவுதான். 2d giving rise to E plus A. equation reverse பண்ணா அதோட enthalpy change value எவ்வளவு வரும், it will become what, minus of the original. So original equation enthalpy change எவ்வளவு, plus 350, right? So if the modified equation enthalpy எவ்வளவு வரும், it will be minus 350. Okay, so முடிஞ்சது, we got the modification for the third equation. Okay, இப்போ நம்ம என்ன பார்க்கணும், we should look at take a closer look at the first equation and second equation. Okay, so இதுல என்ன பாருங்க, second equation we have 2 moles of C coming on the product side. பாருங்க, 2 moles of C coming on the product side, and by the way C is only in second equation only, மற்ற equations கிடையாது. C is coming only in second equation. ஓகேவா, நம்ம overall equationல C எங்க வருது, C is coming on the product side 2 moles only, means what, அந்த second equation நம்ம change பண்ண தேவையில்லை, which means what, அப்படியே இருக்கட்டும். So which is 3 moles of B giving rise to what, 2 moles of C plus D. So enthalpy also as it is வரும், minus 125. ஓகேவா, ஏன் நம்ம இந்த second equation change பண்ணலாம், because C is coming only in second equation மட்டும், and C is 2 moles on the product side in equation 2. நம்ம overall equationல அதே தானே இருக்கா, overall equationல what is the C, 2 moles on the product side. So நம்ம change பண்ணக்கூடாது, we should not be changing it. Okay, now வெறும் equation மட்டும் we have to tackle equation 1. Okay, so இப்போ overall equationல பார்த்தீங்கன்னா A is not at all there. பாருங்க, overall equation A is not at all there. Okay, means in first equation live and the third equation we are having the A, so A should get cancelled. Overall equation நம்ம add பண்ணும்போது A should get what, cancelled. Okay, so இப்போ equation 1 ல பார்த்தீங்கன்னா we have half a mole of A on the reactant side, but in the modified equation பாருங்க இதுல எங்க வருது, A is coming on the product side 1 mole. அப்ப நம்ம என்ன பண்ணணும், அந்த equation 1 அப்படியே we have to multiply with 2 வச்சு multiply பண்ணா என்ன வருது பாருங்க, 2 into half எவ்வளோ, 1 gives rise to 2 into B, 2B. Okay, அதுக்காக because we are multiplying the equation by 2, right, அதோட enthalpy also will be multiplied by the same value. So என்ன வருது பாருங்க, it will be what, 2 into 150, which is going to be what, 300. இப்போ பாருங்க நம்ம இந்த 3 equations add பண்ணா என்ன வருது, A will get cancelled, right? Okay, இதில் பாருங்க இங்கே 2B இருக்கா, இங்கே 3B இருக்கா, cancel ஆகிட்டு you will be having just B only. So அப்போ என்ன, B plus அந்த மாதிரி இங்கே ஒரு D இருக்கா, so we'll cancel 1D. B plus D is remaining on the reactant side. product sideல என்ன இருக்கா, E plus 2C. பாருங்க, so அப்படி நம்ம modify பண்ணா we are able to make a combination, and அந்த combinationலேருந்து when we add up these equations, right, we are able to get the overall equation. So அப்படி தான் நம்ம Hess law apply பண்ண போகிறோம். Okay, so what is it, whenever we are given some equations, right, and we are asked to find ஒரு unknown equation ஓட enthalpy, எப்படி நம்ம approach பண்ணுறது, we will first modify these given equations and try to arrange them as a combination. அந்த combinationலேருந்து add பண்ணா we should get the overall equation. So இங்கே பாருங்க, so first equation நம்ம என்ன பண்ணிருக்கோம், we multiplied it by 2 multiply பண்ணா we are getting the enthalpy also multiplied by 2. ஓகேவா, second equation அப்படியே இருக்கா, we have just kept it as it is, so enthalpy also as it is. third equation நம்ம என்ன பண்ணிருக்கோம், third equation what did we do, we just reversed it. third equation reverse பண்ணா the enthalpy will become negative of the original. அதுதானா, இப்போ பாருங்க 3 equations நம்ம add பண்ணா என்ன வருது, so A is getting cancelled, இங்க 2B 3B, வெறும் 1B will be remaining. இங்க D இருக்கா, இதில் ஒரு D cancel ஆகிடும். So what is it, reactant sideல B plus D, product sideல E plus 2C. ஓகேவா, so இப்போ overall equation of enthalpy change will be what, as per the Hess law concept, it is the sum of the enthalpies of the individual reactions. என்னது, இந்த 3 reactions. ஓகேவா, so பாருங்க 300, அதுக்கப்புறம் minus 125, minus 350, எவ்வளோ வருது, it is coming as what, minus 175. So இந்த Hess law பேஸ் பண்ண ஒரு ப்ராப்ளம்ஸ் எல்லாத்துலேருந்து தெரியுமா, we should first plan எப்படி அந்த காம்பினேஷன்ஸ் நம்ம கொண்டு வரதுன்னு சொல்லிட்டு. ஸோ ஒன்ஸ் யூர் ஏபிள் டு கெட் த காம்பினேஷன், ரைட், அவ்வளோதான். இட் இஸ் மோர் லைக் ஒரு basic mathematics question மாதிரி. Okay, அதுக்கப்புறம் என்ன இருக்கும், you just have to add பண்றதுதானா. So main task என்னன்னா, we should think about what is the right combination. Okay, right combination எப்படி, you will be usually doing what, either multiplying the equation by a factor or dividing by a factor, இல்லனா reversing that reaction. இந்த மூணு இதுலேருந்து we will be able to modify the equations. Modify பண்ணதுக்கு அப்புறம் you should make the combination. அந்த combinationலேருந்து we should get the overall equation. இப்போ இந்த இதில் பார்த்த மாதிரி we modified the first equation, second equation. I mean second equation நம்ம modify பண்ணலாம், but அந்த combination நம்ம add பண்ணா we are getting what, அந்த overall equation வருது. Okay, so that is the reason why the enthalpies of these reactions is equal to what, அந்த overall equation ஓட enthalpy. Okay, another question paranga, this is the question that has come in the 2010 paper. For an endothermic reaction, energy of activation is EA and enthalpy of the reaction is delta H. Both the values are in kilojoule per mole. Okay va, the minimum value of activation energy will be. Okay, so even in one of the previous question we நம்ம இந்த activation energy relation to the enthalpy change of the reaction and the concept நம்ம பார்த்திருக்கோம். Okay, so பாருங்க, if you have any reaction, right, normally நம்ம activation energy ன்னு சொன்னா தெரியுமா, it is the energy difference between the reactants oda energy level and the intermediate. What is the activation energy concept? It is the energy difference between the reactant energy level and up to the intermediate energy. Okay, so this is also actually enna theriyuma, the activation energy is also the activation energy of forward reaction. Equilibrium concept la paakumbodhu you will have what, forward reaction இருக்கும், அந்த மாதிரி you will also have a backward reaction. இது பாருங்க, இதன product, இதனது, this is the activation energy of the backward reaction. Backward reaction also will have activation energy, right? அதனது அந்த product energy level and the difference between the product energy level to intermediate energy level. Okay, அதுதான் activation energy of the backward reaction. Okay, so என்ன relation என்ன, for any given reaction, right, enthalpy change is equal to what, activation energy of the forward reaction, அதுதான் நம்ம இந்த EA ன்னு சொல்லுவோம். Okay, minus activation energy of the backward reaction. For every reaction there will be a backward reaction, right? So இப்போ பாருங்க, இதிலிருந்து EA ஓட வேல்யூ என்ன, இந்த backward reaction ஓட activation energy நம்ம left side எடுத்துட்டு போலாம். What is it, delta H plus activation energy of the backward reaction. பாருங்க, this is what is the activation energy of the forward reaction. This is the activation energy of the forward reaction. Okay va, so inga parunga, they are asking the minimum value of activation energy will be. Okay, and the activation energy oda minimum value enna nu solittu they are asking. Okay, so what is it, because this is an endothermic. So endothermic enna theriyuma, product energy will be more than the reactant energy, adana endothermic reaction nu sonna. Okay, so which means and the backward reaction or activation energy will be lesser. This value will be what, less. This will be what, lesser. But still any reaction, right, and the activation energy value cannot be zero. It will have some value. It will be having some particular value. Okay, appo நம்ம என்ன சொல்லலாம், the activation energy அதோட minimum value whatever. So இங்க நம்ம 1 னு வெச்சுக்கலாம், even if it is like 1 or 0.5, whatever it is, activation energy of the forward reaction, right, will be definitely என்னது, it will be definitely more than the delta H oda value. எப்படி நம்ம அந்த comment பண்றது, because it is like what, activation energy of the forward reaction is equal to delta H plus something. Okay, and the something oda value will be some, it will be having, you know, 1 or 2 or 3, whatever it is. Okay, so you are adding some value, right? That is the reason why the minimum value of the activation energy, what we will say, it will be always more than the delta H oda value. It will be always more than the delta H value. Okay, அடுத்து என்ன பாருங்க, the standard entropies of x2, y2 and xy3 are 60, 40 and 50 joule per Kelvin per mole. Standard entropies. Okay va, means S0 values, not represents what, and the standard conditions oda value. Okay, for the reaction half x2 plus 3 by 2 y2 gives rise to xy3. Delta H oda value கொடுத்திருக்காங்க. What is the delta H value? Minus 30 kilojoules. okay. So you will have to be always careful about these units. The S is in what unit? Joule per Kelvin la varudhu, but the delta H value is coming in what? Kilojoules. Okay, what is the question? For the reaction half x2 plus 3 by 2 y2 gives rise to x by 3, delta H value is what? Minus 30 kilojoules. To be at equilibrium, the temperature should be, they're asking what is the temperature where it will be at equilibrium. So equilibrium means del G value is equal to what? Del G value should be equal to 0 as an equilibrium condition. Del G negative means spontaneous, del G positive it will be what? Non-spontaneous. Okay, so means and the delta H value should be equal to T delta S, means delta H by delta S should be equal to the temperature. In the temperature value we will be having what? Equilibrium. Okay, delta H namakku theriyum. What is delta H value? Minus 30 kilojoules, but namakku delta S requirement irukka. Okay, how do you find the delta S? Because reaction kuduthirukanga. What is the reaction? Half a mole of x2 plus 3 by 2 moles of y2 gives rise to x by 3. Okay va? So delta S is a what? It is a state property dana. It's a state property, means delta S of that overall reaction is equal to what? The product soda entropy minus reactant soda entropy. Okay, like the way normally nama enthalpy and sonna, what is the enthalpy change? Enthalpy change is equal to what? Product soda enthalpy minus reactant soda enthalpy. And the internal energy change and sonna, what is it? The internal energy of the products minus internal energy of the reactants. So the product and x by 3 oda x by 3, where is it? X by 3 is the third value, right? Another 50. Okay va, paranga inga 50 varudhu. The product oda entropy minus reactants entropy. Reactant entropy theriyuma, we have half a mole of x2. So x2 oda molar entropy oda 60, half a mole in that, it will be what? Half into 60 another 30. 3 by 2 moles of y2 irukka. See, y2 oda value anna 40, right? 3 by 2 moles means 3 by 2 into 40 varum. Idu parunga, 2 1s are 2 20s are total level 60. Okay, so we have to multiply by the number of moles. So then our the overall this is coming as what? 50 minus 90 means minus 40. It will be what? Minus 40. This is what is the standard entropy change. But in another we will make a small assumption. Assumption in the entropy change is remaining constant with temperature, and the assumption we should make. Okay, entropy change will also depend upon temperature. Actually, the standard condition measure panna at a different temperature, the value might be changing. But what is the assumption we are making? The delta S value is remaining constant with temperature, means we got the delta S naught. What is it? Minus 40 joule per Kelvin per mole. So we will take it as delta S. At any temperature we take the same value. Okay va? Final step, right? What is the temperature? It is what? Delta H by delta S dana. That is the temperature where we will have equilibrium. Paranga, delta H is what? Minus another 30 kilojoule. Kilojoule means what? Into 10 power 3. நம்ம ஜூலா கன்வர்ட் பண்ணனும். ஓகேவா? டெல்டா S எவ்வளவு? minus 40 joule. Okay, so இதுல per mole வரும், இதுல joule per mole per Kelvin. Joule per mole cancel ஆயிடும், அந்த Kelvin மட்டும் it will go to the numerator. Minus minus will get cancelled. பாருங்க, this is what? Okay, so 3000 by 4 Kelvin. That's the temperature value. What is 3000 by 4? This is 750 Kelvin. பாருங்க, what is the answer? 750 Kelvin வரும். So இதில் நம்ம என்ன பண்ணிருக்கோம்? First we are getting the entropy change for the given reaction. அதுக்கப்புறம் we are using the equilibrium condition. Equilibrium condition is what? Del G oda value should be equal to 0. அதிலிருந்து we are getting what is the corresponding temperature. Okay va? அடுத்த question பாருங்க. This is the question that has come in the mains 2010. என்னது? 3 moles of an ideal gas expanded spontaneously into vacuum. So நம்ம இந்த இது பத்தி we are already discussing once before. என்னது? This is what? Expansion in vacuum. Expansion in vacuum and சொன்னா this is what? Free expansion தானா? Where the external pressure value will be equal to what? 0. Expansion in vacuum என்னது? The external pressure will be 0. Work done will be how much? பாருங்க, theoretical question. Okay, so work expression என்ன? General expression minus integral P external dV. This is the work general expression. Okay, work order general expression. Okay, any process we can use it. Okay, now idhula expanding in vacuum and sonna paranga ippudi oru system edutittu you just think about it. Okay, so inga nama gas irukka, idu movable piston, veliya enadhi veliya vacuum and sonna what is the P external value? 0 dana. So P external nama 0 substitute panna, what is the work going to come as? 0. So when a gas is in free expansion or an expansion in vacuum, in the corresponding situations la what will be the work value? Work will be always equal to 0. Okay va? Or the question enna paranga, this is the question again, mains 2010. For vaporization of water at 1 atmospheric pressure, the value of delta H and delta S, delta H kuduthirukanga, delta S also, idhula em theriyuma, always keep looking at the units. Generally on the delta H value, del G value, del U value, it will be in kilojoule. Delta S and theriyuma, it will be in joule. You have to be careful about it. Okay va? The temperature when Gibbs energy change for this transformation will be 0. Straight question dana. What is it? At what temperature the Gibbs free energy change or Gibbs energy change will be 0. Okay, what is it? Delta G should be 0. Means what? Del G, what is the Gibbs Helmholtz equation? Del G is equal to what? Del H minus T delta S. This is what you call as Gibbs Helmholtz equation. Idhula they are saying del G must be 0. Okay, means what? That is the equilibrium condition dana. So del D is equal to 0. Del G 0 means del H minus T delta S should be 0. Abanago delta H value will be equal to T delta S. Adalanda we are asked to find what? Temperature dana. We are asked to find what? Temperature. So temperature will be, then paranga temperature is what? Del H by delta S is the temperature value. But the calculation pandradhukku munadi we have to be taking care of the units part. Paranga del H avada 40.63 kilojoule per mole. We have to convert this into joule. Joule anam maatano. What is it? 40.63 into 10 power 3 varu. Okay, del S avada 108.8 joule per kelvin per mole. Substitute panna del H by del S, right? 40.63 into 10 power 3 divided by 108.8. So approximately adoda value enna varum? It will be coming as what? 373. Unit will be what? Kelvin. What is the value going to be? 373.43 approximately. Paranga, what is the option we can choose? Option C. Okay, out of the question paranga, this is another question based on the Hess law application. The following two reactions are known. First reaction another Fe2O3 solid plus 3 moles of CO gas gives rise to 2 moles of Fe solid and 3 moles of CO2 gas. Adukana what is the delta H value? Minus 26.8 kilojoule. Other equation anna FeO solid plus CO gas gives rise to Fe solid plus CO2. Okay va? Adukku what is the delta H value? Minus 16.5 kilojoule. They are asking what is the delta H value for this unknown reaction. What is it? Fe2O3 solid plus CO gas gives rise to 2 FeO solid plus CO2 gas. First we will just write down the reactions. And then reactions kuduthirukanga. First reaction is there. Okay va? Adukaprom second reaction. First reaction oda enthalpy change namakku theriyum. Second reaction oda enthalpy change namakku theriyum. Namakku enna venum? Third reaction oda enthalpy change venum. Okay, so what we are going to do? We are going to see எப்படி அந்த ஈக்குவேஷன் 1 ஈக்குவேஷன் 2 நம்ம மாடிஃபை பண்ணணும். மாடிஃபை பண்ணி ஒரு காம்பினேஷன் மாதிரி கொண்டு வந்தால் அதுலேருந்து we should get the overall equation. ஓகேவா? ஸோ அந்த மாடிஃபிகேஷன் பண்ணுறதுக்கு முன்னாடி what is the normal thing that we will analyze? இப்போ ஓவரால் ஈக்குவேஷனில் பாருங்கள், Fe2O3 is coming 1 mole on the reactant சைடில் வருது. ஓகேவா? ஈக்குவேஷன் 2ல Fe2O3 வரவே இல்லை. Fe2O3 is not at all coming. எங்கே வருது Fe2O3? It is coming only in equation 1. equation 1ல it is coming same 1 mole on the reactant side. அப்போ நம்ம equation 1 we should not be changing it. ஏன்னா that Fe2O3 is coming as it is, right? ஸோ அப்போ equation 1 நம்ம சேஞ்ச் பண்ணக்கூடாது. ஓகே பாருங்க, So equation 1 என்னது Fe2O3 plus 3CO gives rise to 2Fe அதுக்கப்புறம் 3CO2 okay அதோட enthalpy change அப்படியே வரும் what is it minus 26.8 kilojoule ஓகேவா இப்போ என்ன பண்ண பாருங்க because in overall equationல overall equation பாருங்க இதுல Fe கிடையாது பாருங்க is Fe there no okay but நம்ம அந்த first equation நம்ம அப்படியே எழுதினா அதுல Fe வருது Fe is coming as what 2 moles on the product side ல 2 moles வருது but overall reactionல you should not be having any Fe வரக்கூடாது so அப்ப நீங்க second equation பாருங்க second equation Fe எங்க இருக்கா Fe is there on the product side Fe is there which side product side ல இருக்கா ஓகேவா now what we are supposed to do we should reverse it first நம்ம என்ன பண்ணனும் we should reverse it okay reverse பண்ணா what you are going to get பாருங்க reverse பண்ணா என்ன வருது Fe plus CO2 அப்படியே அந்த reaction அப்படியே reverse பண்ண போறோம் ஓகேவா gives rise to FeO plus CO reverse பண்ணா enthalpy will become what minus of this means minus of minus 16.5 means what 16.5 தானா reverse பண்ணா we are getting 1 mole of Fe on the reactant side but நமக்கு cancel பண்றதுக்கு we will require 2 moles of Fe on the reactant side தானா means what இப்போ நம்ம இந்த ஈக்குவேஷன் அப்படியே எடுத்துட்டு we should multiply by 2 பாருங்க 2Fe plus 2CO2 gives rise to what 2FeO plus 2CO so we are multiplying by 2 means and the enthalpy change also will be multiplied by 2 dana which means what 16.5 into 2 எவ்வளவு that is what 33 kilojoules ஓகேவா இப்போ நீங்க பாருங்க இந்த ரெண்டு ஈக்குவேஷன் எடுத்து நம்ம ஆட் பண்ணா Fe cancel ஆயிடும் ஓகேவா இங்க என்னது இதுல 2CO வருது இதுல 3CO so வெறும் we'll have 1CO ஓகேவா இங்க 2CO2 வருது here 3CO2 so வெறும் we'll have a CO2 on the product side பாருங்க what is the final expression Fe2O3 plus CO gives rise to what 2FeO plus CO2 அதுதான் நம்ம equation 3 means for the equation 3 enthalpy change will be equal to what in the equation of enthalpy which is minus 26.8 plus 33 what is it minus 26.8 so 33 minus 26.8 என்னது what is it 6.2 தானா 33 ல இருந்து subtracting 26.8 subtract பண்ணா எவ்வளவு வரும் it will be what plus 6.2 so that is the enthalpy change for the third reaction so இதுல நம்ம என்ன பண்ணிருக்கோம் we are looking at the overall equation approach என்ன அந்த given equations நம்ம ஒரு combination மாதிரி எடுத்துட்டு we should arrive at the final equation okay அந்த combination எப்படி கொண்டு வருது we will keep looking at the அந்த overall equation or final equation பார்த்துட்டு அதுல எங்கெங்க ஒரு particular substance வருதுன்னு சொல்லிட்டு அதுக்கு ஏத்த மாதிரி we will be doing the combination so இதுல என்ன பண்ணிருக்கோம் first Fe2O3 is coming in the reactant side 1 mole equation 1 ல மட்டும் we have the Fe2O3 that is also 1 mole அப்ப என்ன அதுல இருந்து நமக்கு வர clue equation 1 நம்ம அப்படியே எடுக்கணும் we should not be changing it okay அதுக்கு அப்புறம் overall equation Fe கிடையாது so நம்ம என்ன பண்ணிருக்கோம் இந்த equation 1 ல இருக்கிற Fe எப்படி cancel பண்றதுன்னு சொல்லிட்டு அதுக்கு ஏத்த மாதிரி we just modified the second equation okay va so what is the answer for this option B அடுத்த question பாருங்க this is a question in the 2009 the values of delta H and delta S for the reaction என்னது carbon graphite plus CO2 gas gives rise to 2CO gas so delta H கொடுத்திருக்காங்க delta S also இதுல என்ன தெரியுமா பாருங்க delta H kilojoules ல வருது okay this reaction will be spontaneous at so என்ன கேக்குறாங்க at what temperature the reaction is spontaneous இதுல என்ன they are giving four values of temperature 910 Kelvin 1110 Kelvin அதுக்கு அப்புறம் 510 Kelvin then 710 Kelvin okay first என்ன தெரியுமா spontaneous ன்னு சொன்னா the del G ஓட value must be what negative del G negative right that is the condition for the spontaneity okay so இதுல delta H எவ்வளவு 170 kilojoules means 170 into 10 power 3 joules delta S எவ்வளவு 170 joule per Kelvin பாருங்க del G negative means what del G is what gives Helmholtz equation right del G is del H minus T del S should be negative, means del H should be in the minus T del S நம்ம right side எடுத்துட்டு போலாம். It will become what? Plus. Okay, இதுக்கப்புறம் we will bring the delta S to the left side, denominatorல போயிடும். Okay, so del H divided by del S should be less than T. இது நம்ம இங்கொன்று மாதிரி எழுதலாம், அது T should be more than del H by del S. A less than B and சொல்லலாம், இல்லைனா we should say what? B more than A. Okay, so temperature ஓட value should be more than what? Del H by del S. இப்போ என்ன பாருங்க, del H எவ்வளோ? 170 into 10 power 3 joule. Del S is what? 170 joule per Kelvin. So இந்த 170 cancel ஆயிடும், joule cancel ஆயிடும். Okay, so என்னது 1000 Kelvin means அந்த spontaneity வரத்துக்கு the temperature should be more than what? 1000 Kelvin. Temperature level should be more than 1000 Kelvin. பாருங்க, where is that answer? Temperature more than 1000. இந்த இருக்கிற ஆப்ஷன்ஸ்ல what is it? வெறும் option B. மற்ற எல்லா ஆப்ஷன்ஸ் பாருங்க, option A is what? 910, option C is what? 510, option D என்ன இருக்கா? 710. மற்ற இதில் temperature is what? less than 1000. வெறும் option B ல மட்டும் we have temperature more than 1000. ஓகேவா? So this is how we can answer this particular question. இல்லைன்னா we can also அப்படியே நம்ம செக் பண்ணலாம், என்ன தெரியுமா? del G is what? del H minus T delta S தானா? ஓகே, ஸோ ஒரு வேல்யூ நம்ம எடுத்துட்டு டெம்பரேச்சர் வேல்யூ எடுத்துட்டு we can keep checking. ஓகே, that is not of course recommended. செக் பண்ணனா நீங்கள் ஒரு டெம்பரேச்சர் எடுத்துட்டு அதில் சப்ஸ்டியூட் பண்ணால் you will be able to check whether the del G பாசிட்டிவாக வருதா இல்லைன்னா நெகட்டிவ் வருதான்னு சொல்லிட்டு. ஓகே, so if you substitute temperature as 1110 substitute பண்ணா அதுக்கான what is the corresponding del G ஓட value? It will be coming as what? minus 18700 joules வரும். Then you can conclude that the reaction is spontaneous. Okay, அப்படியே பண்ணலாம், but that will be like, நம்ம என்ன பண்ண போறோம்? We are going to simply ஒரு ஆப்ஷன் எடுத்துட்டு we have to substitute. Okay, so this is about the question that has come in 2009. So அதுக்கு என்ன answer? What is the answer for this? Option B is the answer. Okay வா? So this is about the part 3 video and part 4 video பார்க்கலாம். Okay வா?